Thanks everyone again for coming today. To recap what we'll chat about, we will discuss some of the biggest challenges we are seeing with data today, both the data quality itself and the data environments that those pieces of data tend to live in. We'll talk about what data mesh is and give an intro to data governance. And finally, I'll share some tips on how to mesh both of those together by applying design thinking to data governance. I am a service designer who has years of experience working with data specific products and services. And this work has really taught me that data governance is not the technical problem that people tend to think it is. It is really first and foremost a culture challenge. And I think applying some design thinking techniques to it can really reframe how you approach the challenge and co-create data governance that it creates more cohesive standards that you can automate throughout your data mesh. So some information about me. I am a civic tech designer of data and digital-based products, including websites, databases, and strategic advising services. I work and have worked for the last 2.5 years as a service designer at Steampunk, which is a human-centered design firm serving the federal government. So we work on projects with agencies ranging from CBP and DoD to USDA, which is where I have been for many years. We do work with USAID. I am currently in my role at Steampunk advising an CDO, an Assistant Chief Data Officer at a US federal agency on data strategy, specifically which data services the CDO should offer the rest of the organization. And Steampunk, I should say, is hiring. We are hiring actively across roles in design, front-end development, ServiceNow engineering, Drupal development. So if you are looking for another job, feel free to either message me in the chat or find me on LinkedIn, because we would love to hear from you and we are actively recruiting. I also recently wrote a book. I wrote a book through the Pragmatic Programmers called Designing Data Governance from the Ground Up, and you can go to that link there if you're interested in purchasing a copy on any e-reader, or you can also purchase a print copy either through PragProg as the publisher or through another book publisher and seller like Barnes & Noble or local bookstores. And I've been in tech for about 10 plus years now. I started as a reporter covering the sector from Europe, and I've been contributing to open source communities for 5 years, including Drupal. I was also a community correspondent for opensource.com for several years, and I speak regularly at events like Open Source Summit North America, and I will be there next month in Vancouver if any of you will be there as well. So to get started on this concept of data governance and this talk on data mesh, I wanted to create this intro slide. This is a little tongue-in-cheek, and it's a graphic from Jordan Tagani of motherduck.com. The idea here is that you start any presentation on data with this kind of ubiquitous graph showing that the volume of data is going up, and by X amount of time period, there will be Y amount of data, which is incomprehensible to us now. And that in and of itself is presumably a benefit. It's presumably a good thing, because by virtue of having a lot of data in your possession, that in and of itself is enough for your business to succeed, right? And I think we all know that this is not the case, that there are actually a lot of real challenges with managing data at the volume that we see today. These quotes are cited, or statistics are from a survey that was run within the last year, and they showed some pretty damning statistics. So data volumes in this survey grew by 63% per month on average. The mean number of data sources per organization was 400. So that means that many people in the survey were saying that they were ingesting data into their organizations from 400 sources, some more, some less, but that's a high number. 99% said that they will migrate to the cloud over 2 years. That's not so surprising. But what's maybe not also surprising is the fact that 90% of execs said that it is hard to prepare data for analytics. In other words, it is hard to go into the environments where this data lives. It's hard to even know which data lives in which environment. Then you have to go in and find it. You have to clean it and prepare it for external use. And that is a challenging task. And when it comes down to why this is challenging, at the end of the day, change is hard. 1 in 4 leaders in a different survey said that they're data-driven. They repeatedly cited cultural hardships as greater barriers to being data-driven than technical blockers. And one other thing to say about that 1 in 4 statistic is the fact that this number is down. It was 38% that said they were data-driven just 2 years ago, and 1 year ago that number dropped to 1 in 4. So the volume of data is increasing. Meanwhile, the number of executives who say they work for data-driven orgs is decreasing. So it's not hard to see the challenge there. And if you work in production environments, if you work in DevSecOps, you see the consequences of this. There's an oft-cited statistic that approximately 13% of machine learning models make it to production, which means that you are investing time, money, and resources in the form of people in making models that never even see the light of day. And then even if they do see the light of day, there's still a lot of work to be done to get them ready to constantly be ingesting the data that they're going to encounter in the wild, which often differs from what they were first exposed to. So the work just never ends. It's a never-ending cycle. And if you don't have a really strong backbone, it's very easy to fall behind. And I think this really is encapsulated by a line from a song. Everybody wants to change the world, but no one ever wants to change themselves. In other words, if you are not invested in doing the boots on the ground work of establishing data standards, of defining what quality looks like in your organization, and then automating those standards in your architecture and dev environments, you are going to really continue to spin your wheels. And sometimes the challenge is if you are in a position to be driving that change, it's something that would really benefit you and the rest of your organization to be thinking about how you can start creating those standards to manage data more effectively. The good news is that there are solutions to these challenges we talked about. They can ease these issues. And one of those solutions is federated data governance. It can help solve these problems because it automates the standards that you need to decentralize your data. I always say when I give this talk that if you remember only one thing, I want you to remember to automate your standards. And so when we talk about data governance, and we'll define it in a minute, we often think about it in a purely compliance way. We think of it as being in this vacuum, or it being a role where someone defines what you can't do with data, which inherently means that they're impeding innovation. And the reality is that data governance should never be divorced from your production environment. It's really about co-creating standards for quality, defining how data is fit for use, and then automating those standards throughout your environment so that you are able to apply those standards to all the data in your environment before you start standing up data mesh architecture and investing in more advanced tools and techniques like machine learning. So when we talk about what data governance is, especially federated data governance, we're talking about a marriage of two things that yield a third. So when we're discussing data governance, we're really talking about a strategy to manage the people, processes, and tools related to how your org stores data and its associated metadata. It's also standards which share how your org collects, stores, processes, and destroys data. If you do not have data destruction policies or storage policies, that's a big red flag, especially if you deal with data on consumers from Europe, because due to legislation, they have rights about figuring out how their data is used. And governance should always be scaled with the goal of improving service delivery. So again, you're never doing governance in a vacuum, or at least you shouldn't be. It should always be a set of people, processes, and tools that is scalable so that you can apply it across pipelines, models, anything else that you're working on. And one way to put governance into production is to stand up what's called data mesh. This is a concept that was first introduced by Zhamak Dehghani in 2019 when she was at ThoughtWorks. And data mesh promotes a data as products mindset, which is quite a shift from how data has historically been managed. So mesh is less of a singular tool, technique, or purpose. It is really meant to be a mindset that helps you figure out how to manage data domains as respective products, but you keep them in the same environment. By doing so, you keep the data available in self-service architecture, which is what the data mesh refers to. And this also ensures that data is formatted, stored, and discovered against equal standards. That's why it's so important to have governance established before you start standing up data mesh, because once you have all of those data products in there, you are going to be executing those standards that you set. And so it's really important to have them before you invest in the architecture. And when you do invest in the architecture, that results in something called federated data governance. And this is where automate your standards comes in, because this is where you automate your governance standards throughout that decentralized architecture, which is the data mesh. It also guides domain-specific data stewards through the process of building data products and also retrieving various data products for their own respective use according to the access standards that you've set. And it also defines parameters for how your colleagues can build, define, use, and access data products within that data mesh environment. So once you start with the data governance and then incorporate it into data mesh in the cloud architecture, then that yields federated data governance. And that is where the standards you set become scalable. Now, I will say there are some caveats to data mesh. I mentioned earlier that it was first introduced or mentioned in 2019. It is thus a young, evolving process. And frequently when I talk to clients about data mesh, the question is always, well, what are the precursors to it? What are the case studies for how it's been done successfully? And there are some. I will share one at the end of this presentation to show you what data mesh can look like in practice. But it is still a young and evolving process, which means that it is a mindset and people are still figuring out how it actually works in their respective organizations. But so it is innovative, but it's also risky that way by nature. Data mesh is also not a singular tool, role, or standard. I think in tech, we sometimes get very hung up on the latest language or framework or anything else that we think is going to be a magic bullet for solving all of our challenges. And data mesh is none of those things. Like I said, it can be referred to as a type of architecture, a type of decentralized architecture, but ultimately it really is about a mindset of how you manage data. And so it is not one singular off-the-shelf tool that you buy. And then finally, the last warning is that you really cannot do data mesh well without governance. If you are trying to build machine learning models without data quality standards, without having a data catalog, without knowing which servers each data set lives on, you're really not going to get anywhere. And this is a challenge I run into often. I will work with my data architect and data engineer peers to do assessments on behalf of clients. And very often those clients have very grand views about the things that they want to do with big data, and they can't articulate what their data quality standards are. They don't have data stewards in place, and it is difficult, if not impossible, to succeed if you have not done that foundational work of deciding what governance looks like. So that brings us to a question. If data mesh is risky, if it's not a magic bullet, why would we even consider it, especially when it's so new and still in the process of being proven? There are some core tenets to data mesh that I think make it a really valuable principle. And if you are interested in standing up a cloud architecture, if you're interested in making data more accessible and creating an environment that allows you to not only scale your standards, but have other people in your org access your data more effectively, data mesh does have a lot of positives. First and foremost, it is a domain-driven design, which means that you are designing your architecture environment to ensure that every large data domain is accounted for, and that so everybody knows where the data in that respective domain lives. It also creates more autonomy for the teams managing those domains, because the idea with both data governance and data mesh is that you should have cross-functional data stewards who are owning the data in those domains. They are making decisions about the data definitions, the quality standards, the pieces of metadata attached to it, the meaning within data. And the idea is that those people should have more of a say in the data quality standards that are then implemented throughout the pipeline. So this does not mean that we are turning a sales manager into a data engineer, but it does mean that if the sales manager is the most senior leader in the sales organization and they're the one responsible for the data in sales, that they should therefore be a data steward and have more of a hand in defining what quality for sales data looks like. And then on top of that, you do have in data mesh a decentralized microservice architecture, and this yields a lot of big benefits. One is that data domain owners, aka data stewards, get more autonomy to know, own, and make decisions about the data in their purview. Data mesh architecture also supports cross-domain data analysis, and so it allows people within your organization to access data more easily because they know where it lives and they know who to make the request from, and it can be streamlined more effectively. It also interconnects data, and this is very similar to APIs and a microservice architecture. So within data mesh, you have the data domains that are respective within the larger data mesh environment, but then they are also interconnected, and they connect to one larger data catalog where people can not only request the data that they need, but then receive it. And so then that makes the pipeline from ingesting the data into data mesh architecture to giving it to the right user more purposeful, and it's able to be delivered faster at higher quality when done well. And so when we think about the 4 phases of federated governance, we're talking really about 4 things. The first is interoperability. This defines the parameters that allow data stewards to leverage data products across the data mesh architecture. There's also documentation. This helps everybody learn how to find and use the various data products within the data mesh architecture. There is security, which sets role-based access by creating identity and access management policies within your cloud platform. And there's compliance, which automates requirements for your legal rights, PII, all of that within the data mesh. So all 4 pieces of this are really crucial to doing data mesh well, and they are a form of governance that ultimately helps you do more with the data you have and deliver the right data to the users requesting it faster. And this is a snapshot of what it can look like in action. So you have these data standards that you integrate into your engineering practices. You put these into an enterprise data lake that is going to control aspects of your data, including scanning, measurement, access, lineage, and validation, among others. And then at the end of that, you get scalable evidence-based data governance. And so that is where you are able to share those standards, not just in your environment, but with your users, who therefore have more trust in your data, because we know from various sources and surveys that trust in data is at pretty historic lows. And so if you want your users and customers to trust the data that you're putting out, it is really important that you invest in the right infrastructure to make it happen. But it's not just about infrastructure. It's not just about tools. The reality is that if you don't invest in building a data-driven culture, your data mesh efforts will ultimately fail. Because if you have not invested in finding the right people to own the right data domains and access data in the data mesh environment, all of your work is for nothing. And so if you don't make data ownership a core tenet of your organization, then everything we talked about can't really bear fruit. And I think we're past time, the time of having all the data in one organization be owned by one leader or by one team. The reality is that there is too much data out there today for one person or team to own it. And we really need to, as tech leaders, invest in educating and training the rest of our teams so that they are empowered to not only understand understand the data that they have, but make decisions about its use that benefit themselves, their jobs, and the rest of the organization. And the thing is that to reap the rewards of data mesh, you can co-create governance with your cross-functional team. So if this is sounding really overwhelming to you, the good news is that this is not something that you are meant to be doing on your own. It's actually the exact opposite. As the most senior data leader in your org, this job of creating a data strategy does fall to you, but you are not meant to do it by yourself. So if you choose the right leaders, aka the right data stewards in your organization to join your efforts, you can start doing a lot more with the data that you have. And that's really where the book title came from, Designing Data Governance from the Ground Up. I wanted to reframe data governance as a design challenge because I think it is often thought of as pure compliance. It's often thought of something that is theoretical or divorced from quote unquote doing the work. And the reality is that if you don't start from the bare bones, then you can't do any of the big stuff later on. So today, to close out, we'll talk about a few tips to get started. If you don't have a data governance program in your org yet, but you are interested in standing one up, we will show you how to do that and then ultimately get you started on the path towards creating data mesh architecture. So the first step that is really crucial when doing this work, when starting to define what data governance looks like, is to answer two key questions. What is my company's mission statement, and how does our data use fulfill that mission? And when I share these questions with people, the first one in particular is so basic, it can almost seem offensive. You might be sitting there thinking, I already know what my company does. Why do I need to answer this? Like, I know what I do on a daily basis. I know what my job is. So why does it matter? It matters because every organization exists to offer value in one way or another, and they are ingesting and putting out data that either reinforces or disproves those values. And so the other aspect of this is that I meet a lot of C-suite executives who can articulate what they're working on, which tools they use, which tech stacks they want to buy, but when you ask them this first question, they struggle to articulate it. They can't fundamentally define why their organization exists, and they get so in the weeds of the technical aspect of data that they don't even understand why they're really using it or how they're using it. And the other reason these are important questions to answer is that if you don't know how data fulfills your company's mission, I am guessing that you don't also know where that data lives, or which format it needs to be converted to, or whether there are duplicates, or who owns which data sets, how it's ingested into pipelines. There are a lot of open and ended questions that arise when these two questions do not have clear answers. So defining that is the first key step for any data leader who wants to go on this governance journey. The second key aspect of this work, once you've answered those two questions, is to define data domains. And so this involves answering some more questions about figuring out what are your organization's key areas of interest. In other words, how would you, as a data leader, segment the data that you have according to genre, according to role, to area of the org. So one really basic example is that you very likely have sales, marketing, and product data in your organization. Those are three examples of data domains. Another thing to consider when you're defining these data domains is how is your organization structured and architected as is? What are the functions that exist? Who reports to whom? That is also going to give you an idea of which data domains you currently have. And then the final question, which is the most important for the next step, is you want to figure out about who leads each problem space and its associated data. So for instance, if customer service is one key area of interest, that is a data domain. And then you would want to be looking at, okay, who is the most senior customer success leader in the organization? It is probably the customer success director. And that is really important information because what you're going to do is take that info on data domains and create what's called a business capability map. This is a sample capability map from a blog post written and published by Towards Data Science, which is a great blog on Medium about all things data science. I highly recommend following it if you don't already. And from this blog post, which is linked to on the screen, you can see something called a business capability map. So here what we're looking at is 4 data domains with respective subdomains underneath. So this person has chosen to categorize the data in their org, which is a flight company, similar to, it's an airline similar to United Airlines, but it's hypothetical. So this person working at this hypothetical airline has chosen to categorize their data according to 4 domains, and then they have categorized the data underneath those domains according to these subs. The specifics are less important than looking at the overall structure. So as you look at this business capability map, I want you to be thinking about your own organization, your own possible data domains, and then thinking about respective subdomains, where once you have your sales data, which types of sales data do you have? You probably have inbound leads. You also have outbound leads. Those are 2 examples of subdomains that you can put into your business capability map under the sales domain. So this is a way of applying, design techniques, thinking techniques to data mapping and governance, because you want to paint a really clear picture of what you have before you can move forward and make it better. And making it better involves appointing domain-specific data stewards. So when we talk about data stewards, it's often thought that these are people that you hire from externally outside of the organization. I have seen job postings for data stewards on LinkedIn, and I am skeptical that that is the way to go, because one of the biggest value adds that data stewards have is that they are already part of your organization. They already know it really well. They are experts in their respective domains, and they are already doing the work. That's something else that's really important to emphasize, because when my colleagues and I are trying to sell our clients on data governance and data mesh, the first question we often get asked is, how much time is this going to cost? Because they are going to have to sell data governance to their organization, to their people, and they know the first question they're going to get asked is, how much more time am I going to have to devote to this? And so one of the benefits of data stewards should be that these are already leaders in your organization. They probably already manage teams. They definitely already have data in their respective domains that is crucial for them to succeed at their jobs. And then the idea is that you bring them together in a data governance council to co-create the standards for data governance and really to define what data definitions, quality, metadata looks like in each specific domain. So then you have 4 hypothetical data stewards here, all of whom would manage the data for their domains within an organization. And then they would all collaborate with each other to define those standards before they get automated in the architecture environment. And part of that work that stewards do is defining what data quality looks like. When we talk about data quality, we're talking about data that is fit for its intended purpose. In other words, is the data fit to be shared outside of your organization? Is it meeting guidelines for personally identifiable information masking? This is something that comes up with my clients often. They often work with very sensitive data, and so they need to really be sure that they are masking that data when they are using it in production environments. And so creating standards for that is really important. Defining data quality is not an easy or short exercise. It does involve a lot of work, but if you are looking for a starting point to get going, this is a good way to go about it. You can get really granular by defining what your data domains are, your respective component names per domain, and then the goals for use, success conditions, and failed conditions. And there is a lot more that we could say about that. I think there could be a whole different session on just data quality, what it is, how to define it, and what it looks like at different organizations. But again, we're starting granular here. We're assuming that you're starting from scratch and you do need to start somewhere. So regardless of whether you're working with customer success data or legal data, you have to define what success looks like with that data and what failure looks like. If you are monitoring that data, you have to know when the data has gone bad, when data drift has occurred. What does that look like? How is your team going to recognize that? That's what you uncover during the process of defining data quality standards. And you've probably been thinking, well, this might be great, but what does this actually look like in practice? You mentioned that data mesh is only 4 years old, not even. Who is doing it and who is doing it well? There are some examples out there of companies that are investing in data mesh and they are sharing their journeys. Medium tends to be a really strong place for articles on data governance and data mesh. And I've seen people writing about their experiences implementing it at startups. I've also seen, as you see here, implementation of data mesh at large multinational banks like JP Morgan. So this is a case study that is taken from the AWS blog. JP Morgan partnered with Amazon Web Services to build its data mesh architecture. And so what you're looking at here is a map of the business processes on the top left. So that really goes back to the governance we talked about, that it assumes that you have your data domains defined, you have your data stewards in place to own those domains, you have defined what data quality looks like, and then you start operationalizing those processes within product-specific data lakes. So you might remember that we talked earlier about managing domains as their own areas within a more decentralized architecture environment. So here what you're looking at is 3 respective domains. They are all on their own. They all have their own catalog for the respective data domain, but then all of that connects to the broader mesh catalog. And so that's where your data definitions live. That's where all of the information gets centralized and interconnected with each other. And then from that mesh catalog, that is where you hook up all of your consuming applications, and that is how people ultimately get the data that they need. So you are managing data according to domains in a much more clean, cohesive way, rather than having all data live everywhere. But then all of those respective domains connect to the mesh catalog. And then from there, from that catalog, that's where your consuming apps get hooked up. And ultimately that data can spread to the right people. Here, we're also looking a little more granularly at how this can look for one specific domain. So you have your business process, whatever it is, you have the operational system, and then ultimately that information goes into both the data domain data lake, and then you also have the product owner for that data domain, and they are the person in charge of not only overseeing the content related to their domain in the data catalog, but they also are that person who is approving requests for data. So on the far right, you see a consuming app owner, and you can see that this person is looking for data that they can request from that particular domain. Because JP Morgan has set up its architecture this way, this person can go to the data catalog. They are able to make a request for data in the Red Lake. That request goes up to the product owner, who is the data steward, and then they can approve or deny it depending on the security standards that they have set for their data domain. Where possible, you want to standardize as much as possible, but given the nuances with data, this is not always the case, and it's not always possible or best practice. So that's again where your expertise comes in as the product owner. And so you want to be that person who's making decisions about who can access it, where the documentation is. And so people know who to go to and where to go in order to get and consume the data they need. And when they do consume that data, they can be more assured that it meets standards that have been vetted, and that ultimately builds trust in the data, along with creating a more data-driven culture throughout the organization. Because really what you're looking at here is implemented by a technical team, but what this tech team has implemented is those co-created standards for quality and collaboration that everyone in the organization had a hand in. And so when we summarize what we talked about today, the 4 key takeaways really are that done well, data mesh does let teams access, develop, and manage data in a more autonomous way, while also giving them more ways to co-create. And that's really important because data is very often siloed. And so we really want to get away from that with data mesh. It also gives your data stewards an easier way to keep your data secure and to make it more accessible to more people, because ultimately what you do when you create a data-driven culture is you give more people not just a hand in defining what success looks like, but you also give them ways to learn more about what it means to be data-driven and how they can relate data to their own respective roles. But the catch is that data mesh only works if you've done the hard work to create a data-driven culture and automate that culture standard. So you cannot do the fun stuff with decentralized architecture if you have not done that work of governance. But the good news is it is doable. So I want to thank you again for having me here tonight. Virtually, and apologies again for not being able to be there. I would have loved to be there in person to chat with you, but I am available online. So you can find me on LinkedIn if you would like to connect. I'm also in the DC Tech Slack, and you see a link up there to my book on this subject. It's called Designing Data Governance from the Ground Up. It does focus more heavily on the culture aspect of data governance and how to really build a data-driven culture. And I wrote it for senior data leaders at organizations. I wrote it for a DevSecOps audience to try to establish that data-driven culture in your own organization. So if this topic resonated with you, I would love for you to buy the book. If you enjoy it, I would really appreciate any reviews you can give. Those really help new authors out. But I want to, in the meantime, thank you for taking the time to listen today, and I hope you have a great rest of the evening.
The first time for everything. This is our first virtual / in-person speaking event here. Any questions? Banjo in the back. I don't know, Lauren, you can't technically see him, but I'll help facilitate if you can't hear him.
Sure. I know you said there isn't any tool to help with data governance right now, but I'm starting to see some. There's an AWS one called AWS Data Zone. I don't know if you've seen that, but it's there's a lot of things going on. So I think tooling will come. Just getting your thoughts on use like AWS Data Zone or other tools.
Yeah, so I think the question, if I heard it, was that was about tools for data governance, and there is no singular tool for data governance, but there are for sure tools to assist with this. And so the 2 biggest that I know of that are the big players in this space are Informatica and Colibra. Now they can be stopgaps for many organizations because they're pretty extensive tool suites, and they can be very costly depending on how much data you have, depending on the package that you buy, how many seats you buy. So I think the bigger challenge is less about tooling and more about people not even knowing enough to frankly to really have demos and be able to evaluate what's out there in the market for their own needs. The other thing that I run into is I'll work with clients who say that they want to implement a data catalog, and we will suggest a tool like Informatica, and they'll say, oh, well, we already use Informatica, and we say, oh, how are you using it? Or like, what's your licensing agreement? How many seats do you have? And very often that's kind of where the conversation stalls, because they know that they're using it, but they're clearly not using it to its full capabilities. And so in terms of tooling, I would say start by looking at what you already have, because it's very possible before you go out and buy a new tool or evaluate several tools that you already do have at least one or two tools in your kit that address data governance and can help you get started. From there, you can look at what other tools might integrate or how you might maybe upgrade what you already have. So when we think about data governance, if I had to choose one tool that I really think is pretty crucial, you need a data catalog. There's no getting around it. And so then it becomes a question of which one, which package, etc. But I would say the big players in that space are Informatica and Calibra. If you are working in AWS, there are other tools in the AWS world that facilitate that as well. One of our clients uses Athena. And so there is a lot out there, but I think if you have not already even started to think about what data governance is and looks like, it's very hard to make an accurate decision about which tool to buy.
Any other questions from the audience? Yes.
Yeah. Great presentation, thank you. I believe on slide 13, you had a slide on a sort of data mesh architecture. And I think you said that you had characteristics for an enterprise data lake, and one of the list characteristics was scanning. Is that security scanning?
Yes. So that was intended to be a reference to security scanning. And so the idea there is that you would do it that way. So that was really the reference there. This is, security is its own beast when it comes to data governance. But the idea here is that you would be doing, security scanning for data in this environment where possible.
Cool, thank you.
Yep.
Just to keep time for our next speaker, if you have any further questions for Lauren, her information is found on the meetup page. You can find her link for her book as well as her LinkedIn page. So be sure to connect with Lauren offline. And Lauren, you're welcome to stay here and check us out here virtually. And if you have any questions in the chat, by all means, you can definitely do so. Feel free to join online as well if you'd like to engage with Lauren through the Zoom. Take a 2-minute break here. We're going to go right back to our next speaker. And again, thank you, Lauren, for your presentation today.
Thanks, everyone. Thanks for coming.
All right, folks, I think we have everyone back, and thank you again for your patience with our virtual speaker setup with Lauren. So again, please feel free to connect with her offline. We are having our first interactive. There's plenty of whiteboards, and I'm trying to see it virtually here, so it picks up on the recording, so that's not what you're seeing us at this right now. But of course, without further ado, anything else?
Thank you for the meeting. All right, everyone. My name is Emmanuel Maffeo. I'm the CEO and principal engineer at Mechanicode, and what we are is a federal consulting shop. I actually used to work at Excel about almost 10 years ago, so it's been a while. And I used to work at Upside before. I know you always get Upside and you bought Upside, so okay. A lot of links over here. But I'm going to be doing a talk about acing the cloud architecture DevOps interview question. With one question that I think kind of covers everything. So now that I'm on the hiring side of things, I've noticed that when I start talking architecture with DevOps folks, I begin to lose them because everyone's kind of like an expert at a certain tenet of DevOps. So in my opinion, the tenets of DevOps, there's 4 of them. There's infrastructure as code, infrastructure as code. There is CI/CD. There is observability, and then there is security. And the way I want to do this talk, I haven't done this before, so I'm just kind of spitballing right now. So if y'all disagree or you have other opinions, feel free to speak up. I want to hear it. So for everybody in the room, does anybody need a definition of what infrastructure as code is? Sure. All right, so infrastructure as code, you can think of it as let's say you're building some resources at AWS, like you have VM. It's a way of saving the state of that VM in a code base so that you have like an auditable trail, and you can also recreate that VM if you ever need to in the future. You can like do all your configuration with code, and it makes deploying it to multiple environments very easy because you can deploy the same code to every single environment and it's built the exact same way. So that's a quick definition for infrastructure as code. And when you talk observability kind of dives in more of like the SRE realm when you're talking about monitoring and alerting, so on and so forth. Security speaks for itself, finding vulnerabilities, figuring out remediations, that type of stuff. CI/CD, how do you get applications to your cloud environment? That's that big bucket over there. So, am I missing anything?
What does CI/CD stand for?
Oh, continuous integration and continuous deployment. Thank you, man. So we are going to answer one question, and this question is draw an e-commerce storefront in a cloud environment. That's it. That's all we're going to answer today. Draw an e-commerce storefront in a cloud environment. And so we're going to use these whiteboards to architect what that's going to look like. I'm going to stick with AWS because that's what I know the best. But if y'all also want to interact and draw too, you can feel free to use those boards over there. You can compare and contrast. I've got extra markers over here. But also, it's going to be interactive. So I'm going to ask for prompting questions. Am I missing anything? Do you see me doing anything erroneous? I want us all to kind of like do this together. So let's draw something very simple. All right. So yeah. Yeah, Ben, I got some markers here if you want. So what I like to start with when we're drawing architecture is boundary. So our boundary right now is yeah. My boundary right now is AWS. Boom, keeping it really simple. My e-commerce storefront add an app. What am I deploying my app in? Let's use an EC2 instance. An EC2 instance is a virtual machine instance. You can think of it like a cloud. So let's call this my VM, which is EC2. My code has.
You want to at least be in a.
Oh, sure, I do agree with that, but I'll touch on that right after this, because I think that's a good prompting question to dive into. Now my app has to also live somewhere, so let's come up with a version control system. Let's use a popular one like GitHub. So let's just call this my GitHub app code, which makes it my VM. So, and then let's say, because it's a storefront, you want to store customer data, so you need to store this in a database. So let's just call this database. But in AWS, it most likely would be an RDS instance. And that's it. That is a very dead simple architecture view of an e-commerce storefront in AWS. But as you mentioned, Carrie, that there's things that are missing. Well, you typically want this in a virtual private cloud. Why?
So that it's protected and you don't contend with everybody else for IP addresses.
100%. Because AWS has the concept of you could just deploy your VM in their public IP address space. Because like maybe you don't understand how to do all the networking stuff. You can do it very quick and easy, and they'll just say, have at it. But if you really want to be secure, you want to wrap this up in a VPC so that you can control all the network that goes in and out of your VM. Now, Carrie, is that enough?
You probably want CloudFront or something in front of it.
Well, I'm talking about the VPC.
Oh, you
Do you want that to also control the database for your whole data?
Right, you want your VPC to also control the database because now your database is living in this public world as well. But if it stays within the VPC, then you can control traffic to and from your database and audit it with like VPCs have a thing called like flow logs. So you can really get to the nitty gritty of let me watch all the traffic going back and forth from my database. And so I will call this, I'll put like a logs document over here. Call this VPC flow logs. And this stuff there. Okay. So we're getting somewhere. Looking a little messy, we're getting somewhere. So we have a GitHub app, we have the VPC that encapsulates our VM, and then our database, and then we also have logs, or if you want to audit what's going on within our network. Now, what else can you do with this?
ECS with or Fargate with Docker containers.
Right, so now that's an enhancement to the VM. So you want to think of, so,
For the VPC network logs, the only logs you have?
no, right, so you also want application logs as well. So where would those go? So let me grab a different color. And so in AWS, those are typically going to be your CloudWatch logs. So I'm going to put like a little, I'm going to extend my boundary because now we're growing. And so now your EC2 VM is going to flow logs into something called Cloud Watch logs. Why are app logs important?
To debug.
To debug, to know what's going on. If you don't have any logs, you truly don't know what's going on with your application unless you're doing like health checks. Is it running? Is it not running? Besides that, you have no other visibility. So you're going to need logs because your dev team is going to want to know what's going on.
Load balance.
You probably want a load balancer in front of it. Why? Why would you need a load balancer? I mean, we could realistically, if I'm on my computer, let's call this computer, I could just hit the VM directly from an IP address and call it a day, right?
You have one VM, why not?
If I have one VM, why not?
Well, but even with one VM.
What's up?
Can I do that at the same time?
What do you mean?
Hit the app, my computer?
Oh, sure. So now we could have like multiple computers hitting the app, right? And how do you manage this load? Because you're a storefront. You're not gonna have one or two customers. You want to have millions of customers. And how do you handle the load that's gonna be bashing this VM over here? So yeah, you're gonna want a load balancer. So, okay, so you have you have user, you got a front end, CSS, EC2, let's add a load balancer to your drive.
Yeah, so load balancer being for the EC2, so I didn't draw it, but it's in this area.
So that should probably be like between,
Yeah.
yeah. So you're gonna want your load balancer between your users and your, whatever you're using for processing. So in this case, it's the EC2 instance. And as we discussed, we want that because you're gonna want to have to manage a whole bunch of users. But that's not the only thing. You're gonna have a load balancer to manage all the users hitting your VM, but it's usually gonna be like an application load balancer you use.
What is a load balancer?
What is a load balancer? You want to give the definition?
I think of it as a way to, when a user requests something, the load balancer is going to take on a request and pass it to a machine with the least amount of resources. So typical way is called bound logging. So if a request comes in, I'm going to take this, pass it over to machine one, another request comes in, pass it to machine two, and go to how many end machines you have, and there's restarts. And lots of other different ways to do it, but that's basically just handles the load for you and submits it against the resources you have.
Yeah, perfect.
And are you all gonna want the same kind of thing to interact with your database?
Right. So now we're talking about scaling, because now we're managing the load theoretically on our one VM. Yeah. DNS, that's also doing some form of DNS. So in this case, let me swap things out. Let me move this white threshold.
I connect to the database through the VPC itself.
All right.
What I'm saying.
So now we got a lot of questions. So I might pull some people up and start drawing some tackle all these. But, we gotta keep this moving. Let's add, DC Tech check. Can I run this up?
Yeah,
Okay.
I'll put it up on this board.
All right. So let's add our DNS. So let's call this kind of block over here. It's usually going to be Route 53 and either in AWS. And that's going to be your DNS server. Right.
All the other,
So DNS, you think of like, in case you're not familiar, just like a domain name, like google.com or bing.com. And your DNS name, let's call this e.com. Is going to route requests and try to get domain name to my load balancer. And you can potentially also do things like geo routing. So like, let's say I'm deploying my VM in multiple regions, you can decide, you can load balance from that perspective as well. But we want to talk about scale because now we have one VM that most likely if I have 1 million users is going to fall with. That's it. So we could scale the VMs potentially. We can throw them in an auto scaling and have multiple VMs that grow and expand based on CPU utilization, memory utilization, so other custom metrics that you might decide, determine how the best
those custom
where those custom metrics come from. Usually it's not value for custom, because I would imagine.
Yeah, that can.
It's like coming to your wall.
Right, so yeah, you could definitely track that within the logs, or potentially you can even use like CloudWatch agents in your code, and you can track it that way. It's a way to give this guy.
No, I know, because it's all the tail end, so it automatically built into AWS.
Right.
So it keys off of memory or other utilization.
Yep. But this is a perfect opportunity to kind of redraw that section and add in something like containerization, right? Because now there's a lot more cooler. Maybe cooler is not the right way, but something much more interesting than a VM, because that's kind of old school. So maybe we want to turn our code base into a Docker thing, right? So now we've taken our app. Let's take this out.
Docker containers where you have your front end and your back end.
So we've now created, but in AWS, so let's see, this is Docker Hub. But this is public, so let's say I want something that's internal, then I would use AWS ECR, which acts just like Docker Hub, but within your network. And then you can also control, who has access to it. You have a lot more leverage on it. But if I redraw just this section over here, and we want to deploy our, give me an example of like a container service in AWS that we could potentially utilize. So we can definitely use ECS. Right. So I usually start with ECS because a lot of people, Kubernetes is so sexy word these days, but it's incredibly complex for most basic use cases. So for the most part, I would say 80% of users can just do whatever they need with ECS. So let's draw that boundary again. We're going to call this ECS, and we're going to have our Docker containers deployed there, and they're going to be running and scaling based on demand.
Because you're gonna always scale your ECS.
Right. Based on the same metrics we would have used over there for scaling, I'm going to draw some with dotted lines to kind of show that they're ephemeral. So you would always have a minimum. So let's say you want a minimum of 4 containers, and then you would scale to maybe 6 based on demand and so on and so forth. What else?
Have multiple ECS. And
You could have multiple, you mentioned something. That's right, Fargate.
Yeah.
I want to talk a little bit about that. So you could have, basically, you could either manage the VM yourself in ECS, so that that's usually for folks who want a lot more control with what's going on with their host machines and things like that. Or you do this more PaaS way, platform as a service, where is that the okay, so that means you don't own your machines anymore. AWS owns your machines, and they just say, we have a huge cloud of processing power. We'll give you a piece of it, and then you just deploy your app and figure out everything else. So we'll do the management of your VMs and so on and so forth, and that's called PCS target. Which I like because, I like to manage as little as possible, because that means you have a lot less operation and maintenance, headaches, and, if, I've once joined a team where, when I arrived, the entire DevOps team left. And I was like, and there was no documentation.
There's something.
Oh.
Yeah, it was like, okay, so who's supposed to like onboard me? It was like, well, you're supposed to figure it out. And so, and when you have to figure things out, that's when you realize very quickly, I don't want to manage this mess of things. I just want to give it to the cloud providers because they're the experts, they'll figure it out. So so in my opinion, whenever you're building out some architectures, always think about what can I do to reduce the number of O&M I have to manage. So I feel like RDS has an instance like that. Like you have a regular RDS.
Yeah, RDS is managed.
That's true. I could have sworn they had something. No, that's right. Maybe I'm thinking of Aurora. So, okay, so.
Or it's all RDS. They have
Right, right.
Express.
Right.
RDS.
But they bundle all these features now.
Oracle,
Yeah.
they have, the SQL Server, I think is RDS.
Banjo, what's the name of the serverless databases?
About DB?
Yeah.
No, I could have sworn it was like a serverless RDS. Maybe I'm just making.
Or serverless, quote unquote.
I just have a question. So when you're using the containerizations, using Docker, you wouldn't need to do like scaling with like all availability zones, anything like that?
So you could,
Yeah, you want them in different availability.
you definitely could, but
And different regions.
that depends. It depends on how much money you have. And how involved do you want your disaster recovery to be?
What your uptime requirement is. I feel like
Right.
we missed some things on requirements here, because
That's
we're expanding right now.
Right.
Why are we expanding? Why can't we do?
Why
one
are we
database?
expanding?
Database, like, let's stop it.
That is
One
very
thing.
true. Like, why are we expanding? That's great. You want to ask that question because a lot of times people just want to do the latest and greatest, but they don't have a good justification. Yeah. But let's say theoretically, in this case, we have a big opening for our store and we want to be prepared for 1 million users. So that's why now we're expanding.
But it's
Just
just go
think
with like RD with one Docker container and a small RDS, you only pay for what you're using.
Right,
Which is actually probably cheaper than having an EC2
right.
instance with a VM and.
Yes,
everything else.
and that's a good point. I think it's a point that doesn't always get discussed enough, but that's really cost, and that's where FinOps comes into play. I guess it's a growing new sector in DevOps that should really be one of the new tenants because everyone only worries about cost after you're like, wow, my bill is really high. So we should probably do something about it. But yeah, so let's talk real quick about how we would scale that RDS. Because we have one RDS instance, and usually in this type of scenario, I would use Aurora because that already comes pre-baked with a lot of like scaling things like, let's say we know we're having 1 million users hitting our database, but most of them are just doing like read requests for my database. And you can do things like having like a read replica. And that's gonna help line the load so that you can send some requests directly to this read replica clone of the database and have your main database that does all the writes. Like it helps manage loads, it doesn't become overloaded and so on and so forth. It also comes pre-baked, let me write the name here, Aurora, with some DR strategies if you want to take advantage of them.
Postgres,
Yeah,
MySQL, or.
sure. Well, I guess it depends, like, in your opinion, what would you say is the difference between the two? What would make you decide either one?
Postgres.
Postgres is open source, so I mean, I know how to use that, so some people like open source things and they already have workflows on that, so they use
Sure.
Postgres. Like they want,
Is
they
it
did.
Maria?
Yeah.
Is it Maria?
Yeah, another one. MySQL is another one, For's another one, yeah.
So maybe we'll get some more answers in the crowd. MySQL versus Postgres, what would make you pick one over
Postgres.
the other?
Closer to the SQL standard.
Is that the case?
Yeah. Then MySQL, yeah.
Okay. More pleasant. It's more pleasant to write?
I've used Postgres.
Yeah.
Yeah, so.
When you Google it, you're gonna find the answer.
Yeah. You're definitely gonna find an answer. It's gonna be an opinionated answer, for
They
sure.
call them both Aurora.
Yeah, they call it
Extra
gold
rules
rush.
on top of it, so.
Yeah. So I know that sometimes hangs people. They're like, okay, what type of database do I want? Do I need it to be relational? Do I want it to be a NoSQL database? But at the end of the day, I think it's just like, pick whatever's easiest for you. You could always migrate your data later and figure that out. Okay,
Like going from NoSQL to SQL.
well, yeah, that's a little tougher, but you could probably migrate MySQL to Postgres if you ever want to take advantage of like JSON objects and like Postgres or whatever. So don't do it. Questions. What else can we do to enhance this storefront? What aren't we thinking about?
VR capability for data redundancy.
We could do data redundancy, so like Aurora has the option, well, I mean, all the RDS have the option for like snapshots. You can have snapshots of your database, which you want to do in case of a disaster. That's the bare minimum you should be doing snapshots. There's also options of like multiple AZ, so you can have an instance of your database in a different region. Let's say this would be in like region US East 1A, and this would be like 1B. In case A goes down, you have another copy in B. You can get even more verbose, like you can have a whole copy in a whole other region. So let's say you want one in Australia in case of anything. So you can get very verbose with that.
Is there a reason to choose one region over another?
It really depends where your customers are, because now you're thinking about latency. So if all my customers are going to be in the United States, then maybe it might make sense to have deployments in the east side and the west side. And then you can scale from there.
Well, and also in like costs and features, like US East 1 always gets stuff way before everything else. And
That is also true. US East 1 always gets stuff first because they're like the default region for a lot of things, but it's also the first place to go down when there is an issue. So I usually recommend folks deploying in US East 2 just to be safe. Because
does anybody else notice that like AWS always defaults to US East 2 when you log into the console?
they do that now? Because
Yeah.
before it was 1.
See, for me, it was always 2, and I was like, why does it go to 2? Because we use 1. I don't know why it chose 2 for me.
Maybe I like
Yeah, maybe something weird with that in there. I thought it was a sneaky way to try and persuade us to use 2
Yeah,
more.
they need to do it because everyone just builds 1 by default, right? Yeah. So yeah, that's a good question. Regions come into play.
Have we done any kind of queuing or notification system using SQS or SNS over here?
Queuing and notifications. So how would that help us with our e-storefront?
Processing.
Back end, front end stuff.
Do you want e-commerce stuff to be processed async?
That's a good question.
Good question.
Is this the storefront or the ordering system?
Yes.
But now we're diving a little bit more into like application development. How does our app work? Is it just one mono repo that does everything, or are we breaking ordering into this more asynchronous fashion where, let's say, the checkout system goes down, but that doesn't impact the ordering system from still processing and doing whatever it needs to do with the shippers and something.
The finance guy still wants a report on how many widgets have been sold and wants to connect Excel to the RDS database. You connect Excel and the VPC.
Good question. Can I connect Excel? Benjo, how would you answer this question? Can I connect my Excel spreadsheet?
So I didn't use Excel, but I had a solution that has a Redshift table, which is data warehouse. And the data warehouse was taking the data from the databases. So I used DynamoDB, but from RDS. And then once it's a Redshift, you can put an analytics solution on top of that. QuickSight, which is basically like Excel, and you can create dashboard and other metrics and ask questions about the data. So that was kind of my solution, having a cold storage of your data warehouse and then putting that through it.
Use us to bring that Redshift, or are you using DocumentDB?
I use DynamoDB for the order system, but then Redshift is able to just using Athena, you can make queries to that and grab, ingest the data to Redshift, and from Redshift, that's where the cold data is, and you could use for the site of business. You can use the streams or Kafka if you want to, but
Is there a reason you would leave that in the cloud as opposed to writing it somewhere that's more stable, for lack of a better term, just because like, while it would be interesting to have those dynamic analytics, I can imagine that like if you're doing quarterly financial statements for your app or something else where you're gonna have to do a non-automated filing solution, say for your taxes, you're gonna probably want stable copies that actually like report quarterly invoices that have come in by particular dates.
yeah, so the Redshift is a cold database, so it's not anything live is here. This is copying from the
That's your data lake.
data lake, yeah,
Right.
so I don't, exactly, I want to mess with the live database, so this is everything to copy it, so it's perfect for report analytics, offline things.
I think I'd argue in favor of just give a read replica to the analysts people and not do the copy to Redshift. I feel like that.
Sure.
that-
If they know SQL, right? Yeah.
That's more like archive data.
Redshift has some built-in things, but analysts care about, so auditing, other things, if I just want to have, connect my pandas data frame and have a Jupyter notebook, then yes, a read replica is better. But if I'm a business intelligence person, I'm gonna want to use Redshift more than use the pandas data frame.
Okay, if your data is stalled, a read replica is a great thing to do before you go to a full data warehouse.
Yeah, I just, a million customers on one day, I feel like it's not gonna generate enough data for that solution, I would think. I feel like that solution for a million customers for a couple of days.
I agree. I do sometimes think that people start talking about data lakes and all this stuff way early in the game. But that's just my opinion. Badger knows a lot more about that data.
I like the scale.
How much money you have?
You said what?
How much money you have?
Yes.
Right. That's the golden question.
Yeah, because I guess in the application development, how you break it up, front end, back end, to use like CloudFront.
Right.
To put in front of your static website and.
That
and
is-
Stuff like that.
Before we get into that, let's talk a little bit about how do I get my app to this infrastructure? Because that's another kind of DevOps, which is continuous integration and continuous deployment. So we're gonna give that its own board.
That's where the console.
That is exactly the quick way. Graphical user interface, keyboard, mouse. So let's say, in this scenario, I'm using GitHub. Let me see it. Yeah. How's that cat look? That GitHub cat? I know there. So CI/CD, how do I want to do this? So I'm a fan of using bundling tools. So typically, Jenkins is an old favorite. Everybody's very familiar with Jenkins, but I've grown very fond of GitHub Actions because it sits right there in our repos. So in this case, I'm going to use GitHub Actions. And what I'm going to do is, and if you're not familiar with Actions, Actions is kind of like if you've ever used Circle CI, it's like a runner that connects to a server. So in this case, it would be GitHub servers, and then you would rent it from them to run different instructions that you need to deploy. So in this case, let's say I'm going to come up with a very simple scenario where I say, with every pull request, I merge my code into main. And then when I get to main, that triggers a deploy to my dev environment. We didn't talk about how we would duplicate this into multiple environments. We'll discuss that in a little bit. But in a very simple scenario, we could do pull request that merges to main and then deploys to dev. And then we could have from main, we have a git tag, let's say 0.1, and then that triggers a deployment to our staging environment. And then that same copy then gets deployed to prod whenever we're ready. This is a very dead simple. Well, it's not that simple because we could technically just rub all this out and just have one environment called it a day. But if we wanted to be doing things the DevOps way, we have 3 environments. What else can we do here to enhance the experience of getting our code to our infrastructure?
Automated tests.
We need tests. So where would those
You
go?
don't wanna just open up PR and have it go right to me.
Right, so that would happen
Have all the
here.
stuff.
So we would now have unit tests.
And,
What else?
well, once it goes to acceptance test, after it gets deployed,
What are acceptance tests?
basically making sure that everything works, or integration tests, whatever you wanna call
Where would that happen? Would that happen here?
them. No, it happens,
It would happen in your environment, right?
right,
So let's
get
say,
your environment,
so
hopefully before you start taking.
Or staging,
before staging? All right, so we'll say, are these integration or acceptance tests?
integration tests.
Integration tests, is there a difference?
And then some, yeah. I use the term integration tests.
Okay, so we'll call it integration tests. An integration test will test the functionality of like your app. So let's say you have multiple apps and they communicate with each other. It tests that communication flow. Unit tests are usually more specific to the app that has a new feature that's being developed. What else we
Should
do?
also refresh and test later.
That could be covered in unit tests, right?
Yeah.
Yeah. So that would cover like even historical features and all of that. What else are we missing for our CI/CD?
Security scans.
We need some type of security scanning. Where would that come from? I mean, at what stage would that be?
Before staging, so before integration test.
Before integration test.
Or
Before
basic
you
dev?
want to do it before. it goes-
Yeah, before it gets deployed at all.
Yeah.
What if we have this issue right here?
That's true.
Well, where's your build, I guess?
Your build?
Yeah.
What do you mean?
Your artifact.
Your
Yeah, there's
artifact. We
some-
haven't discussed that.
Yeah,
So let's discuss that as well. So let me just write this here. Scanning.
That's just.
We call this security scanning because there's so many scans you can do.
No.
But now we need an artifact. And how are we gonna build our Docker container and where we store and all of that stuff? So where does that happen? That building of the artifact?
On GitHub servers.
On GitHub servers. Exactly. But it would be right after, let's say we've automated this, so we're gonna trigger on a merge to main, to start building your container over here. So let's drop this arrow all the way down here. All right, and it's gonna build a container for us.
well, we did.
That we then push to ECR in AWS. And I'm a big fan of build once, deploy everywhere. So in my opinion, and I'd love to hear other opinions, this same artifact that gets deployed to stage, and it's the same artifact that gets deployed to product. So that you always are secure that it's the same image that one you've done run integration tests on. And so you're already familiar with how that behavior should be for that app and so on and so forth.
And you should, after you build the container before you send it to ECR, or after the ECR, you probably want to do a scan on it because
Right,
you're pulling stuff in when you build the Docker container.
that is true. So let's add.
Is it ECR on the scan?
You
You can enable scanning on ECR, right?
I'm still on your own.
That's true, easier to scan it.
Yeah, you can just enable it and send it, it's their problem. right?
On your own.
But you're talking about.
Shared responsibility.
That is true, that is bundled in CR.
Actually, I do have a question.
What's up?
You want to deploy, you want to build once and deploy once.
Everywhere.
Question, when you go to the tags stage, are you then looking back up to the SHA that was built for dev and tagging it again?
Well.
Or are you doing your Docker build again, because it should result in the same thing? And if it changes, going, oh, I have a problem.
Yeah.
You tag the image in ECR and
Yeah, because if,
Really pull down that image.
That is true, because technically, you could create an image for every merge, so every SHA,
Yeah.
and then you just tag that SHA that's been already built.
the tag goes after you build the image. The tag isn't what goes to staging and prod or whatever. It's the Docker container that goes to staging and prod.
Right, but when we're deploying everything that goes to dev, to staging and prod, you probably want to select a subset. So let's say we've had like 10 pushes to dev, right?
Right.
Let me see how I can draw this. We've had a bunch of pushes to dev, and we were picking this one, because we're like, we tested this particular version. We would then, that's already deployed to ECR, all of them are actually deployed to ECR. And then you just tag this one. And then deploy that to stage, or, yeah, it is like
Yeah,
that.
so it would pull out the UCR, right?
Right,
Or kind of.
so that's how that would work. So you would add a new tag to the commit. So yeah, so maybe we didn't discuss this, but when you're deploying to dev, it would make sense to tag these with like a short shop in GitHub so that you know these are the different versions of dev that match to the code base. And then you just retag whatever you want to push to stage.
What about, considering if you have something like Golang, right, where you get reproducible builds, where you should
Okay.
get the same thing, so all you're doing is build a Golang banner and
Right.
shoving in Document container.
Right.
What about rebuilding it the second time?
Yeah, but I
Just
think
to check the shop.
unless you're like strictly limiting the which library version you're using, then potentially you could get, like, if you just say latest, then something else somebody could have pushed something to a new library that you rebuild.
You should not be using latest.
See,
Hand it to a version that can change without changing the version.
Not if you're using something like, Golang from scratch builds. That should be repeatable. That should.
Right.
The question is, you wanna know, if something can change in your
Right.
build,
Right.
should you be worried?
well, but how would you, that's why you would only want to, you're saying, would you want to know? The only way you're going to find out is when you run it in prod and everything breaks and you say, oh, I learned that it changed.
Or you check, you build again.
Well, but that's the point of building it in dev.
Build again, you check the shop.
But if
right?
you build again.
But if you
you're
build again,
introducing other variables.
Every time you build again, because you're saying build again, okay, in dev, great, now we want to deploy to prod. No, wait, you got to build again, all right, we can do it in dev. No, we want to, at what point do you finally say, this is the build I like? I would say, well, once you've said you like it, that's what you move down, because you tested it.
Yeah, that's true, I like that fresh.
I'm more wondering like the Debian idea of a repeatable build.
It should be,
You should be
yeah,
able to repeat it.
it should.
It should be, if you're not pulling from external.
But it actually takes a long
And that's the
time.
issue.
Pulling libraries, external sources.
That's where the
so-
problems come.
A Node.js library changes.
Yeah.
Like a lot file, right?
I think that's a good argument, or a good conversation, because it kind of touches on why do we pin versions, and if you guys are doing block files and NPM and like Terraform, they're there for a reason, is the fact that it ensures that you're pulling down the same version every single time. And so, like you said, somebody could update an existing version, but now the MD hash on it has changed. That identifies that, okay, this person has done something suspicious and I should probably not pull down that version. So that's where pinning and block files gonna come in. Anything else for CI/CD that we could talk about?
Can I ask, is there an advantage of using Action versus Jenkins, or this is just weapon?
My personal preference, I like that the runner coexists with the code, because then I can pull the developers into that whole CI/CD workflow. Like a lot of time, just anecdotally, I found when I work with devs, they don't like having to move to another tool to do deployments, or having to learn Groovy and how that works within Jenkins files. They don't want to do any of that stuff. But everybody seems to be comfortable with YAML, because YAML is used for a whole bunch of stuff. So GitHub Actions is YAML based, and I found like your devs could learn it, your VAs could learn it, all of that. Everyone can learn that a lot easier than Groovy, just my opinion. So that's why I like GitHub Actions, because I mean, we're talking about DevOps, and DevOps means bringing in other folks who are not ops to help in this shared responsibility model of managing the infrastructure and taking care of the infrastructure and all that.
So in summary, it's closer to developers' experience.
Exactly, it's a developer experience thing.
But then you end up with a lot of shell scripts and stuff to do all the stuff.
You could, but you could also write modules. So the devs could like import modules and then you could then bundle all those batch scripts in one place.
Yeah, but you end up, so it's either bash scripts or Groovy or
Right.
something, because the YAML doesn't tell you everything.
Yeah, the YAML definitely doesn't tell you everything. But yeah, I don't know. I think that's now a developer experience question. That is highly subjective, you know, some people might say, well, just learn Groovy, it's like, well, yeah, you could,
Or code build.
or code build, or all these other tools.
Pipeline, everything's other stuff.
Yeah, but I would say, talk to your team members and see what makes sense for everybody. That's probably the best answer.
I'd say also to GitHub, one login. Isn't that nice?
One login,
Isn't that
exactly,
nice?
yeah, one login,
In your organization, doesn't have SSO.
It's another thing you have to add to the SSO.
Right.
Just,
Well,
it's already there.
SSO always, you have to sign up for the premium version of whatever, and it always costs way more.
That
So
is
for
right.
like little startups, that's
Yeah.
a luxury, unfortunately.
Mhm.
Oh, yeah.
There's an AWS solution.
With that. Oh, that's not really well.
Oh, yeah, if you're small, you can be very agile with Action. for sure. And the cool thing about Actions is that one, GitHub was bought by Microsoft, and if you're already in an Azure environment, you're probably already familiar with Azure DevOps. And I'm assuming there's gonna be a lot more quality of life integration with GitHub and Azure in the coming years, because that's the only thing that makes sense. I mean, there's a concept of GitHub action runners. So I told you all earlier that if I'm using Actions, I'm using borrowed VMs from GitHub, who's now Microsoft. But if you want to host it yourself for security purposes or just having more control, you can host your own VMs, like your own EC2 instances, and run your workloads within your virtual private cloud. Now, the most popular library out there, which is Arc, which is Action Runners Controllers, that was just taken over by Microsoft. So it's all like these signs that there's one day in the next 2-3 years, it's gonna be like a push button click in GitHub that says, I want to use runners within my Azure environment, and poof, it's done. But right now, it's kind of very main. Right, exactly. Reinventing Heroku, yeah. These conglomerates are definitely trying to take ownership over everything, but that's a whole other conversation. Okay, so we talked about CI/CD. We didn't talk about infrastructure as code. You have a question? I think I heard somebody say.
Oh, how about not putting your DevOps in the same BTC as your applications running?
What do you mean?
You don't want to put your DevOps and
Mhm.
everything where it can mess with your.
Like within the same environment.
Yeah,
Okay, got it. Yeah, so there's definitely, you want to logically separate where you run your DevOps workloads, just to have, a separation of concerns. If your DevOps pipelines break, they're not running on the same EC2 instance as your app, and that doesn't overload it. But my favorite infrastructure as code tool is Terraform. I guess it's like HCL, it's like proprietary language, but once again, it's a personal opinion. I think it looks cleaner than a lot of the solutions out there. There's other options like, what's it called? There's Ansible, but Ansible is more like configuration management.
No, I mean, you can do all of AWS and Ansible. I've built
Right,
all of it.
right. There's also CDK. There's like it starts with a P. Pulumi is
Yeah.
another one. But those ones, CDK and Pulumi, kind of geared to more so to the devs, because now you can do infrastructure as code in like Python, or like Node and all that stuff. So if you are truly an enterprising organization that wants your devs to also write code and build infrastructure, then you might want to pick one of those tools. Else, there's other options where it's gonna like, with Terraform, you can use the same language in multiple clouds. So if you're working in a multi-cloud environment, you can use Terraform in AWS, you use it in Azure, you use it in Google Cloud. You only have to learn one language. CDK, as far as I know, is still AWS specific, though I think they released like CDK for Terraform, which is interesting. So I don't know how that works.
yeah. But the CloudFormation templates actually get new features
Right.
after Terraform does.
Yeah, that
They
is
actually
also.
fall behind.
That's 100% true. So there are costs and there's pros and cons. CloudFormation, in my opinion, very clunky to deal with, but it gets the most features and you can do the most with it.
But not as soon as Terraform gets.
Not as, and you won't get those features as soon as Terraform gets it. Because it's a first class citizen. It's AWS's own way of doing infrastructure as code. Azure has their own, which is ARM templates. The same thing is there.
What do you do with when you use Terraform? What do you do with state? Where do you store your state?
Oh, yeah, let's
In
talk about
like
that.
S3 or
Let's do
use
that.
HashiCorp's answer?
So a very simple answer is, it depends.
Good question.
Sounds like you're talking about tech.
So Terraform, how do you want to manage your code with Terraform? Terraform has a concept of like your state, it's kind of like a snapshot of your infrastructure in a JSON file. You have options, you could store it locally within your computers, and so you have a state file within your local computer, but that's not helpful if you have a large team and it's more than just you doing work. So you want to store it remotely. You can store this remotely in an S3 bucket. Or some form of like blob storage. So if you're in Azure, you would use like a storage account. They all kind of just take any type of file and then store the state there, storage account. So that's one, and you want to make sure, of course, this stuff is all encrypted. Let's put it in a block. By default,
You can use, I think HashiCorp sells a service.
They do.
they have a service, Terraform Cloud. I'm in the Fed space. They usually don't want to pay for stuff, so I don't have the opportunity to use Terraform Cloud. So I end up having to do a lot of this stuff the manual way. But Terraform does have a cloud option that does this for you. Which is gonna get into another thing that I want to talk about, which is locking. So when you are building your Terraform, and I can probably talk in that, so just let me know.
You have 8 minutes.
Cool. So, how do you manage your code base for Terraform? Because, you know, when you have a large team, Terraform, when you're working on deploying new code, it has a mechanism of locking the state so that nobody else can make changes while you're making the change. Is to make sure that the state kind of stays in like a seamless order of things and doesn't get out of hand. But that can slow down the team because now only one person can be working on infrastructure at any given time. And if you have a team of 30 DevOps engineers, that's just not it. So usually, what I'll do is I'll break my Terraform states into a few categories. So I will have, we're going to talk about TF state. And I will have a networking state. I will have a IAM state, and IAM is more so for like identity and access manager, like managing users and roles and so on and so forth. I would have a app layer. I would have a database layer. And then potentially I would have a security layer for doing like security, like, I don't know, like things like AWS config and things like that. Usually I break it down into these 5 categories, just so that it helps alleviate the state locking issue that tends to happen when you have large teams. Now you could get even more granular than this, but this is just a high level thing. In the places that you've worked, are there other categories y'all typically use for breaking down the state, even more to help alleviate state locking issues?
Different apps.
Sure. So every app could potentially have its own state. So
Yeah, you don't want to lock the whole stack.
right. So if you have a lot of apps, you would have one state potentially per app. What else?
So that's different from having like different main files or like a virus file or something like that.
Right. So it'd be more so you have multiple configuration files.
Okay.
So each configuration file is going to be configured to store that Terraform state somewhere in the S3 bucket. So if you think of an S3 bucket like a file directory, you can define how you break down your state based on your files. So you might have like a parent networking directory or a parent directory, and then within that directory has subfolders for the individual apps that is managing state.
And do you do it as like dev test prod for networking as dev test prod, or do you do dev test prod, which then has, like, where do you put the dev test prod division? Higher or lower than those?
All of them have their own dev test and prod individual states, because you need a place to test this stuff. So if you're gonna be playing around with networking, you don't want to play around the networking in an environment that will affect prod. You want to do so in an environment like dev, where you can break things, and yes, devs might be bad, but it didn't hurt. So I usually break them down, even more by environment.
Sometimes I use like an infrastructure environment that is specifically for testing my Terraform, so that I'm
Sure.
not like messing around in the dev environment
Right,
and breaking it while I'm just trying to figure out how do I build something with Terraform.
so that is true. Once again, you have money, you can have your own infrastructure environment, which is specifically for that type of use case, testing whatever you want, so
So
on.
you
and
could
so
do
forth.
ephemeral environments.
You can do it for remote environments.
That basically like you tag your whatever at the end, so that, you know, your Lambda name is something dash, 01.2,
Right,
whatever. But yeah, it gets expensive because you basically have your own stack.
right.
Well, but you could make it small, like you don't have to blow it out to
You
the,
can make it
you can make
small.
it small. The other
Right.
thing, do you use different accounts? Like I actually do
Yeah.
a whole different account for each one of these environments.
So actually,
Then a
that's a good
master
question for Banjo, because didn't you just create like a chat GPT for well architected?
Yes, I made a
Yeah.
chat bot.
Right.
There you go.
Took all the text from the well-architected framework that we can ask it questions, so
Hmm.
want to ask it a question?
Yeah, yeah. I think that is one thing AWS does recommend in that well architected framework of theirs, that you have one account per environment.
Have you found a good way to do that in Terraform? Creating
Terraform?
new sub-accounts in
Right.
Terraform has just been a pain.
Like using
human
organization.
Making new.
Yeah.
That's all I was thinking, organization.
Yeah. Like, I actually have to like, I found a module that like helps me do it,
Right, right.
but it also, there's some timing aspect to it.
Huh.
Where it'll go to create,
Right.
and if it runs too fast,
Right.
I'll get an email after it's done and just rerun it, and then it'll be
Ah.
fine. There's like one state that if it
Right.
runs too fast, it
Yeah.
doesn't get there before AWS does something. And then sometimes it runs slow enough where.
You know what I think it is? I don't even think that's a Terraform issue. I think that's a cloud formation issue. Because isn't blueprints behind the scenes or
It's
organization is all cloud formation?
Yeah.
Yeah, because you'll see those stacks running as the account is getting. Yeah, and I'm not a fan of cloud formation. That's just breaking on me, but that's a whole other conversation. What's up?
It might be basic question, but how does Terraform handle like, STS assumed role?
Handle which one?
STS like assumed role.
Oh, assumed roles. Okay. So now we're going to talk a little bit about like role-based access and things like that. So I believe that with Terraform, within your configuration file, you can actually set a role that you wanted to use. So you no longer, so the old way of, so we're going to talk about running out of space. I'll do it over here. So this is like Terraform authentication, right? What's up? 3 minutes. All right, I'll speak really quickly. Actually, you know what? I won't even draw it. I'll just yap about it. Terraform authentication. How do you get your Terraform to authenticate with your AWS environments? Usually, you use a service account with like an access key or secret key. But over the years, we have learned that nobody ever like updates or mutates those secrets. And so now you want to use things like roles. So with a developer or anybody else, you can assign them a role to use. Let's say they have an engineer allows them to do things in the database. This role will now create temporary credentials. I think it's like 1 hour duration. And then you can use those credentials to authenticate the user to do whatever they do in AWS. The same concept is there for Terraform. You can assign it a specific role and say, hey, yes, you have a user account, but your user account can do anything. You are now allowed to assume this role that can do stuff, but with a specific duration. So let's say I'm giving it 30 minutes duration or 1 hour duration, and those tokens are always going to be rotated. So it's not something static. The reason they do that is because if I left the company today and I walk away with like AWS access and secret key, I can still use these keys outside of the company on my own local computer and then do all sorts of stuff, crypto mining, whatever. You know what I mean? So yes, does that answer your question? Okay, cool.
Did we get hired?
What's up?
Did we get hired?
Yes, we all did it. We made it to the end. I'm exhausted. I don't know what to talk about.
Thank you for that, and for the visuals too, Manuel. Thank you so much for that. Again, please connect with your speakers today. We have Emmanuel right here with us, and of course, Lauren from earlier. Please connect with them. This is our lovely speakers, Lauren from earlier, talking about data mesh architecture, and of course, Emmanuel right here, speaking on how to. And I think we're all hired, right? Because we did it perfect.
I do want to say just a quick sentence. So even though we talked about all this stuff, I just wanted to highlight that there's so much more we could dive into this and get really, really deep into it. But DevOps isn't about being a master of everything. So as you know, you can be an expert and just know like these tenets at a high level, and then choose what interests you to dive into. So just kind of want to throw that out there.
Who knows? We might get a part 2 out of Emmanuel.